And this time, I will make sure also that I am sharing my screen. Hi, yes, good morning. Welcome to our official start of our second week of Big Data. We have in our class repository here, a new folder has appeared, this topic 1 MapReduce folder. And again, in general, the way the class will be formatted is that most weeks will correspond to one of these topics. Some of these topics will span over 2 different weeks, but most of them will be 1 week. And there are a number of these topics already in this future folder. I will be moving them from the future to the main folder as we talk about that topic. In general, I recommend not looking necessarily too much in the future folder, that it serves sort of as our syllabus, our guide outline of what things to expect in the future. But the actual contents of any of those folders is likely to change quite a bit by the time that I move it out here. And so it's really only these folders out here that are the content of the class of what to be looking at so far. And now we are on this topic 1 MapReduce folder. MapReduce, what we'll see is it's this technique for making data analysis programs very fast by taking advantage of parallelism. We will use it on the Lambda server with shell scripting. Again, the Lambda server has 80 CPUs on it, so you'll be able to get an 80-fold increase in some of the tasks that you're doing. For those of you who took CS46, this topic will be a large part review, but there'll also be some new things related to MapReduce that we'll talk about this week. Some announcements before technical things. Our labs have all been graded. So again, there was no due date on these labs, or there was a due date of last Sunday, but there's no late penalty for these labs. And so if you haven't submitted them yet, a couple people haven't, that's okay. I've currently entered a 0 for you in Sakai, but when you do submit them, your grade will be updated with no late penalty. And in general, if ever you are submitting things late, I will enter a 0 in Sakai for you, and then after you submit it, I will just regrade it and enter something above 0. So you don't need to panic if you see a 0 in Sakai. It doesn't mean that that's there forever. It just means that that's what you currently have, and that can be replaced by submitting something. So they're relatively large lab this first week. The messages part, everybody got full credit on that. The Goodreads part 1 here, the main way that people lost points is that I asked you to submit not just the results of your queries, but also the queries themselves. And if you didn't do that, then you lost a point. Or if instead of copying and pasting like I asked, you took a screenshot of your results, that lost you a point. In general, again, if you have text, you should never be taking a picture of text. That is just about the grossest thing that I can imagine as a computer scientist, because that makes the text not readable anymore. For the Goodreads part 2, I was asking you to submit a command and the output of the command, and a handful of people had something weird about the command that you submitted, and you lost a point for that. I put a note in your Sakai response box about exactly what that weird thing was. If you have questions about that, I would be happy to talk with you about that in person. Questions about any sort of grade stuff, I'd be happy to talk about that with you in person. Or grade-related topics would be an appropriate situation to send me an email instead of posting an issue on GitHub. So that's labs. Homework, again, your first homework is due tonight, but there won't be a late penalty, just like the lab. So if for whatever reason the submitting things, getting GitHub Actions, all that is not working for you yet, or you can't figure it out, that's totally okay. You'll have as much time as you need to figure that out. And my overall expectation is that whole process is essentially review for everybody joining this class. So I'm not going to be covering it in detail in the lecture at all. If you would like a sort of lecture style review of it, you can see the CS46 lecture class recording here, which covers whatever you would need to do for that first assignment. Or at the QCL, there's a lot of mentors who have experience with GitHub that can help you out with that. So speaking of the QCL, there's been a lot of good issues posted here. I'm very pleased with how everybody's using GitHub issues so far. And one particular issue about asking for mentor sessions in this class, or if there are mentors for this class. And if you haven't taken a course at CMC before, we do things a little bit differently than Pomona and MUD with regard to mentoring for classes, that we don't have dedicated mentors for each of our courses here. Instead, we have the QCL. Again, it's located very close to where our lab room is, just underneath that cube on the west side of campus. And they have office hours. You can set up one-on-one appointments. You can, and I don't know if they've posted their full schedule yet. I don't, especially their class-specific schedule, but it should be ready sometime this week. And when it is ready, I'll post it up here to GitHub so that you all have access to that. Any questions about any of that administrative stuff so far? Yes.
Will homework always be due on Tuesday night?
Question is, will homeworks always be due on Tuesday night? And the answer is there's going to be like one, maybe two exceptions, but yes, always due on Tuesday night. And labs always due on Sunday nights, and quizzes always on Thursday. So lots of things every week. Good question. Any other questions? Okay, speaking of quizzes, you're gonna have a quiz this Thursday, and I was originally planning on making it a little bit longer, more complicated quiz covering both our POSIX 1 and POSIX 2 notes, but I've decided that I wanted to have a little bit more of a slower on-ramp into the course. So this first quiz, we're going to go over just the POSIX 1 notes. So on Thursday, just the POSIX 1 notes. So just this file right here on this Thursday. Then next week, we'll be doing this file right here, the Shell 2 and a little bit more. Probably in class today, we will go finish all of Shell 1 here and finish most of Shell 2. But the stuff that we talk about Shell 2, not on the quiz on Thursday, only the POSIX 1. The format of the quiz, again, you'll have 4 problems. The problems will be basically the same as these problems in the quiz notes. This note up here explains how I will generate new problems just by either changing the types of quotation marks or adding and removing quotation marks. We haven't talked in detail yet about what those quotation marks are doing, but that's how I will generate new problems. So you'll be able to generate these problems yourself, and there should hopefully be no surprises. During class, you'll have 10 minutes to take the quiz, but I will also be here in this classroom at least 10 minutes, probably 20 minutes earlier. So if you would like more time, you're welcome to come earlier and start the quiz as soon as you'd like. So my goal is that this should not be like a time crunch sort of thing for anybody. Everybody should have as much time as you want to complete the quiz. We'll do the technical details about the quiz here in a minute, but any non-technical questions about what to expect for the quiz, formats, things like that? Okay, last little announcement thing for us. Scrolling all the way down to the lab and homeworks sections down here. I don't have the labs and homeworks posted yet. In general, I won't have them posted at the beginning of the weeks probably, because exactly what we'll be doing for those will depend on exactly how much we cover during the week. But I do have background material posted for the lab that I would encourage you all to complete before Friday. And so you can get started on this now. And these are 2 labs from the CS46 class that go over working with a Twitter data set that is about 4 terabytes in size. So this will be sort of the background material that I'm expecting you to have mastered before the lab material on Friday. We're going to start next talking about the technical stuff on the shell. Any questions about anything before we talk about technical material today? Okay, another reminder is that the quiz 100% open notes. You can have any written material that you would like in front of you, but no electronic material, nothing that requires any sort of electrons flowing through it, batteries or power outlets. Anything that just requires paper, pencils, that's all fair game. So you could bring textbooks if you wanted. I recommend that you bring this POSIX Shell 1 sheet with you with notes annotated throughout about things that you found tricky while going over it. I also recommend you bring that cheat sheet of shell commands with you and to help you in case you forget what any of these shell commands are doing. Last time in class, we talked about this section 1 about pipes, and we reviewed that a little bit during our lab. And we stopped right here in this variable section. So that's where we're going to pick up today. I'm going to change my screen one more time over to here. And now I have a terminal opened on the bottom down here with my quiz notes up here at the top. And we'll be able to go over the quiz problems just by typing them in down here. As you're all getting that out, one last comment about my terminal. So here, this prompt, this is different than the default prompt on the Lambda server. That the default prompt, it still has this $sign, but it has less useful information here over to the left of the $sign. And one of the parts of the background work for your previous lab, last week's lab, involved configuring your terminals so that the prompt looked the same as mine. That's not something that you are going to be required to do. You'll never lose points or gain points from having your prompt over here be the same or different than mine. But it will make following along with the things that I'm doing in lecture a lot easier if your prompt is the same as mine, and it'll make the labs easier to do because the prompts contain useful information over here. Okay, again, for these problems, all of these problems, the first line is always the same. And so I could type that out again, but again, I am a computer scientist, and that means I am lazy, and I don't want to tire out my fingers by typing. So instead of typing, I am on the terminal down here going to press Control-R. Control-R, you can see, brings up this new prompt environment that has a colon over here. And it tells me a reverse search over here. So this is going to search through my history for commands that I've typed in. And I'm just going to start typing this command up here. So I'll type cd semicolon. And you can see that after just typing cd semicolon, this part right over here is what I have typed in. And this part over here is the command in my history that it has found that matches that. And so with only 3 character strokes, I've typed in that entire giant command right there. And now I hit enter. It doesn't matter where my cursor is on that line. I hit enter and I have run that command. Again, what this command is doing is taking me to my home folder, deleting the quiz folder if it exists, making a quiz folder, and then changing my directory into that quiz folder. And the purpose of this first line is always basically just to reset our quiz problems so that every quiz problem has a fresh environment and no quiz problem is interfering with another problem. Again, these sort of shortcuts like pressing Control-R, things that I'm never going to test you on, but if you get in the habit of incorporating those in your own work, you will be much more efficient and much more effective on the labs and homeworks in this class. So variables. The shell, POSIX shell, is a full-fledged programming language, just like Python, C, Java, any other language you've used in the past. And so that means that it has variables. Assigning a variable works the same way that you might expect in most other languages. So here I'm running line 2 saying var equals hello space world like this. And now to have access to that variable, I have to put a $ in front of this name right here. So the name of my variable, var, in order to set the variable, I just have the name to the left of the equals, but in order to access the variable, I need the $. Rather than running line 3 up here, I'm going to run an echo command, echo. Echo is a great debugging tool because it doesn't change what files are on your computer at all. And so it's a great debugging tool to inspect variables. And if you're ever confused about what's going on in the middle of a quiz problem, echo is the tool that you should turn to in order to see what's going on. And here, if I want to inspect what's inside my variable, I type $var, and this will print out the contents of that variable for me. This $ right here, we say this is doing variable substitution because it's taking the value of this variable and substituting it right here as a parameter to the echo program. Notice I'm going to press the up arrow now, come over here, delete the $, run that, and without the $, then it just literally prints the string var down here. So in the shell, because we don't have, everything is a string by default, because of that, in order to access a variable, we have to put this $ here to let it know that this is not a string, but an identifier, a variable. The touch command, this is a new command that we haven't seen before yet, and what the touch command is going to do is it's going to create a file with whatever the name is over here if that file name does not exist. So I'll do an example first of saying, we'll run ls, another idempotent operation. Idempotent means that it doesn't affect anything. Echo and ls, both idempotent. And so these idempotent functions, these idempotent programs are great for debugging because they don't affect anything. So I can run them as many times as I want, and they're guaranteed not to affect the output of my final line down here in any way. They're guaranteed not to affect the state of the Lambda system, the Lambda server in any way. So running ls right here, I see that there are currently no files on the in this folder, but then if I type touch var like this and type ls again, then it does create this file right here, var. So the purpose of the touch command is just to create an empty file with this name over here, and it will be used very often throughout these quiz problems in order to create files that the ls command on the last line will count how many files were created. Okay. So that's the VAR file. I will delete this VAR file like this. ls, nothing exists. So now we're back to the state of part 3 over here. And I'm going to run this touch command one more time, now with the $var in front of it. And if I type ls like this, we can see that there is a hello and a world over here. Hello world. This begs the question, though, is this one file or is this 2 files? That it's a little bit hard to tell down here whether this is one file with a space in it or is it 2 separate files. If I use the ls, we call ls-l, the -l stands for list, give you the long mode of the listing of the directory, and every file has one row that corresponds to it in the ls-l command. So here we can see that 2 files were created, one whose name was hello and one whose name was world. This is a little bit weird with how variables work in the shell, is that when variables are expanded, here when this $var is expanded, when touch $var, when I ran that, again, we call this variable substitution or variable expansion, where I put the value of this inside of it. The value of var was hello world like this. And so this is 2 separate parameters that are being passed into this touch program over here. Doesn't matter how many parameters we have being passed into touch, that's how many files will get created, 1 file for hello and 1 file for world. So even though this looked like 1 parameter, $var, it looks like 1 parameter being passed into touch, it's actually 2 parameters because the variable expansion just literally copies and pastes that right here, and then there's a space here, so it interprets it as 2 separate variables. I hit enter, type ls, 2 separate variables, or 2 separate files. In the context of this quiz problem, the very last line down here is this ls, type ls pipe wc-l. And actually, first, before I do that, I'll just do ls by itself again. We can see that this just has one line on it, one line as the output. And so you might think if I do ls pipe wc-l, the answer might be 1. But ls has special behavior. Ls detects when it has a pipe to the right of it versus when there is no pipe to the right of it. And when there is no pipe to the right of it, in order to save space, ls will combine things onto a single line. When there is a pipe to the right of ls, ls will do one line per file. So here I run that, and we get 2 because there are 2 files here. So ls with no pipe combines file names onto as few lines as possible. In this case, just 1 line, but if it ran over the side of the screen, then it might go onto 2 or 3 lines. ls with pipe uses 1 line per file. This is the only program that we will deal with in this class that has different behavior between the piped operation and the non-piped version of the file. All the other programs that we'll deal with in this class behave exactly the same when they have a pipe to the right or no pipe to the right. So again, for the purposes of the quiz, the answer here, what you would have to write down in order to get full credit would be the number 2. And if you wrote down anything else, including leaving the problem blank, then you would get a 0 out of 1 problem on the quiz. Covered a lot of things there, very fast. Any questions about any of that content? How many people think you absorbed 100% of that? All of it made perfect sense? A couple of people? Maybe half the class? Yeah, that's okay if it's not making perfect sense for you at this point. Again, the shell environment is a very weird environment. It behaves very differently than most programming environments that you're used to. And so it'll take just working with the shell quite a bit and doing a lot of practice of these quiz problems in order to get used to the behavior of the shell. And again, the way to practice for this quiz is to actually just sit down, similar to how we are doing right now, working through these quiz problems one at a time and trying to predict, understand what is happening and why. One of the purposes of these quizzes at a high level is, so I'm going to be very much emphasizing in the quiz problems that I give you these weird behaviors of the shell. So these things like the $var right here, how it can expand into multiple parameters to a particular executable call. I will be emphasizing those weird things in the quiz that you can expect every quiz problem to have at least one very weird thing like that going on. And the reason for that is because these weird things are often the cause of very major bugs in code that you write throughout this course, or even security vulnerabilities in different that have happened in the real world. Later on this course, when we talk about different things in the shell, we'll see how somebody doing something, thinking the shell behaved a certain way, and it actually behaved in a different way, caused a company to lose millions of dollars due to security vulnerabilities. So it's very important to have a good technical understanding of the shell. If you do have questions about anything as we're going over the material today, feel free to stop me as I am speaking, just shout out, or raise your hand and I'll call on you. So this is the first problem here, problem 11. Problem 12 is only different than problem 11 based on, or the only difference is line 3 down here, how there's quotation marks around this $var. So let's see next what those quotation marks do. I'm going to press Control-C down here to take myself to a new line without running it. You see that there's this up-C that got printed every time I pressed Control-C. The up-, like here, right here, is just means control. So this up-C means Control-C. And a common thing that I will do when I'm working in the terminal is after I have, like, I don't know, sort of solved one problem and I'm moving on to something else, in this case, solving a quiz problem, moving on to a new quiz problem, or just anytime I need to like reset my chain of thought. I will type reset in the terminal, give me a whole fresh new start on the terminal, and get started on the next problem here. So again, I'll do Control R, CD, semicolon, bring me back to this first line of the quiz. The var line here, same, HELLOWRLD. And now the only difference here is these quotation marks around the $var. What these quotation marks do is that they enforce that whatever is inside of here is going to be only a single parameter to the single argument to this command over here. So in this case, we're only going to create a single file. If I type ls down here, you can see that we still have hello world being printed down here, but ls has helpfully included that in quotation marks to help make it obvious that this is just a single file that was created by the touch command right here. And so if I type ls pipe wc-l like this, then we get 1 as the answer for 12 here as opposed to 2. And again, the only difference here is these quotation marks. And these quotation marks say it doesn't matter what the contents of this variable are right here when I do the substitution. It doesn't matter what the contents are, whether it has spaces or not. It's going to be just a single parameter, single argument passed to this touch program. Another weird thing about the shell, though, is that there are 3 different types of quotation marks, and all 3 of those quotation marks do different things. In Python, there are 2 different types of quotation marks, and they do the same thing. In Java, C++, there are 2 different types of quotation marks, and they do slightly different things, but essentially the same thing. The shell, the behavior of quotation marks is very different. So here, let's do an example again. Echo $var. So this outputs my hello world like this. Again, the quotation marks don't really matter for the echo command. It doesn't matter whether it's 1 parameter or 2, we get the same output down here. But if I use single quotation marks instead of double quotation marks, then this says, do not perform the variable expansion inside of these quotation marks. Treat this $sign as a literal $sign and just print out $var like this. So single quotation marks, no parameter expansion happens inside. Double quotation marks, yes, parameter expansion happens inside. This leads us to our 3rd type of quotation mark, which is the backtick. The backtick on a US keyboard is, well, this is what it looks like. You can visually see that it looks different than the single quotation mark because it's a little bit slanted over here in my font. Some fonts, though, they look identical, so it can be hard to tell them apart. On a US keyboard, this is the key in the very top left of your keyboard underneath the tilde character and below the escape character. And what the backtick does is it says to execute the command that is inside of this. So if I type echo, and then we'll do an example first here with these double quotation marks, echo hello world like this, then we can see that like this inside of here is an actual command that is being run, or that is not being run, but that could be run. I could paste that right here and it'll be run. And these double quotation marks don't treat this part in the middle as a command. If I press up arrow, change those double quotation marks to the backticks, then this will treat this here as a command. This command will be run very first. Before this echo command over here, this echo command will be run. This echo command will have the output of hello world. We know that because we just saw the echo hello world right here has this output of hello world. And the output of whatever is this command right here inside of the backticks, whatever the output of this command is, that'll be passed as the input to echo over here. And this echo will print those out. So I'll press enter right here. And we also get hello world as being printed. In your lab, you had to use, we saw a similar technique for doing this command substitution, it's called, using the $sign and then parentheses like this. Both of these 2 techniques are called command substitution, and they are 100% identical to each other in terms of what they do. It's just different syntax for accomplishing the same thing. So again, 3 types of quotation marks. Single quotation marks mean this is a literal string. Don't evaluate the contents of this in any way at all. The double quotation marks mean do the $ substitutions inside of this string. The backticks mean that this is a command. Execute this command and take the input, take the output of that command as the input to this program over here. And again, the backticks exactly the same as the command substitution that we saw in lab. Questions? Yes.
So the output of the substituted command actually gets printed.
Yeah, this is a great question. The question is, when we're using the command substitution, either in either syntax over here, does the output of this command get printed? And the answer is that it never gets printed directly. That here, when I take this echo hello world or this echo hello world, again, it's exactly the same whether you're using backticks or this syntax. The syntax doesn't matter. But when you, the shell will run this command for you, it'll basically store the output of this command in a temporary file and then pass that temporary file as the input over here and never display that directly. In this case, the echo command just displays the output over here, and so so it does end up getting printed. But if I were to, let's go ahead, I'll use the touch command here. Let's run ls. We see that we have this file hello world inside of our folder right now. If I do touch echo test like this, this test will be the output of this echo command. So this whole command substitution right here will be replaced by the word test, and that'll be the input to touch over here. I hit enter, and you can see that there was no output on this line. But if I type ls, now we have a file named test in this folder. That answer the question? Good question. Any other questions so far? Yes. Question is this lecture going to be recorded? And the answer is yes, this lecture is being recorded. You'll be able to access this after class whenever you'd like. In general, all the lectures will be recorded and available on YouTube. I'll usually have them posted by the end of the day, and then you'll be able to watch it for review for the quiz or whatever. Yeah, great question. Yes. Question is, down here in the output of ls, why is there these single quotation marks around hello world? And the answer is because the file name itself does not have single quotation marks inside of it, but the file name itself has a space inside of it. And in order for us as a user to understand that this is one file and not two separate files, ls puts this quotation mark around it. It actually turns out that depending on various settings that you have in your terminal, you can configure ls to do different things for this situation when there's ambiguity in the name of a file, but this is just how our system's set up. Good question. Let's see, I want to do a do some examples about what can go wrong when using variables in the shell. This is not something that's going to be on the quiz directly, that I'm not going to, you're not going to encounter these sorts of error messages on the quiz, but as you're going through your own review, you're likely to accidentally do this typo that I'm about to introduce. And so I would just want you to see it so that you know what's going on. And this is another weird thing about the shell where white space matters for variables. So let's do a reset right here. Clear out my terminal, and I'm going to say, so we saw already before var equals hello world like this with these two quotation marks around them. What happens though if I put spaces around this equal sign? Very common thing for Python programmers to do, especially that PEP 8 requires that you put spaces around the equal sign in Python, but it's also common for C and Java programmers as well to want to put spaces around things like this. And I'll hit enter, and you see that we get this error message that says command var not found. And the reason what's going on here is that the shell is interpreting this as a command in the same way that something like echo might be a command. And so if we were to do something like echo equals hello world, then we can see that the output down here is equals hello world because the shell sees this as a command echo. This equal sign is just a string. There's nothing special about the equal sign like there is in other languages. So it's just a string that gets passed as a parameter to echo and printed out down here. So in order to actually do variable assignment, you must not have a space between the name of your variable and the equal sign. If you have a space, you'll get a weird error message that will be hard to understand what's going on. Another weird thing about variables, related again to quotation marks, is that quotation marks don't really matter around about your variable definitions like that. Now, if I do echo $ hello, whoops, not hello, echo $ var, you'll get that it contains the value hello over here. So quotation marks, they don't matter. That it's just a string like any other string in the shell. Whether you include quotation marks or not doesn't affect things. Here you can see that I had a little typo where I used the wrong variable name. In vast majority of programming languages, that would give you an error message. But in the shell, by default, every variable just has an empty value in it. So if ever you are using a variable that's not defined, you'll just get an empty value right there. So it's saying echo, print this empty thing, and so it's printing just an empty thing right here. One last weird thing with these quotation marks and the equal sign, if I go up, 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 redo this line up here, I said quotation marks don't matter, but if I type this, then we'll get an error message where it's trying to run this command over here, world, and it's saying that command world not found. That if you have variable definitions over here, as soon as it hits a space, then it stops defining the variable and starts going to the normal executing command mode of the shell. And so it's looking for this to be a program over here, something like echo hello world. We'll print out hello world, define a variable right here, then run this command over here. And so if you're needing a space inside of your variable names or your variable values, then you have to put it in quotation marks. In general, anytime you're working with spaces in the shell, you have to put things in quotation marks. Again, none of those things that will be explicitly tested on the quiz, but you will likely encounter those sorts of error messages if you're typing these problems into the terminal to try to run them yourself, or in the various labs and homework as you are writing your own shell scripts. You'll encounter lots of errors like this from, and these are the solutions. Make sure you always don't have a space around the equals, and anytime you have a space in any sort of value, it's surrounded in quotation marks. Yes? Yeah, so the question here is that we've seen some ways of connecting multiple commands onto a single line before, namely the semicolon up here and the pipe operator, of ways of linking commands together. And this line right here seems to have two separate commands inside of it. This one right here, creating a variable, and this one over here that's running the command. And why is there nothing connecting those two things together? The answer is that the way the syntax works, there doesn't need to be anything connecting a variable definition to a command being run over here. We will see reasons for why that's the case later on in this class. Technically, this is something called a shell variable right here, and this is something called an environment variable up here. You don't need to know the difference between those at this point, but this is a way of passing information into programs over here. And so this will be a useful syntax for us later. The main takeaway at this point, though, is just that if you are assigning a variable and it has a space inside of it, you need to have it inside quotation marks. So it's not a complete answer to the question. We will get a complete answer later on in this course. But great question. Yes. I'm going to pause the question. We'll get to that later in the course. Good question, though. Okay, at this point, we've seen everything for this variable section, how to deal with variables. This section also covers this command substitution information here on problem 16. You can see we're doing command substitution right here. In this case, there are spaces to the right of our equal sign over here, but because they're inside of these parentheses for the command substitution, that is okay. You won't get an error message. It's okay to say something like var equals echo, 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 like this. No error message because these parentheses are grouping this all together as one thing. There's a handful of very tricky problems here that involve nested command substitutions with different types of quotation marks sprinkled in throughout. Very easy way to miss points on the quiz on Thursday is based on this. I guess I guarantee that there will be a problem of this form like problem 20, where there is a bunch of echoes on a line and a bunch of command substitutions and quotation marks, and you'll have to parse through that and figure out exactly what all of those things are doing. It requires you to understand a lot of things about shell syntax here just to understand what this one line is doing. So let's keep going down, and now on to for loops. So just like every programming language needs to be able to have variables, every programming language needs to have control structures like loops and if statements, and the shell terminal is great at doing that. These for loops are things that I use all the time when I'm automating things on my system, and so that's why it's the first control structure that we'll be talking about. It's probably the most important of the control structures for scripting purposes, but it also has a lot of very sharp edges related to it that are very easy to get confused about what's going on, and the quiz will definitely test those sharp edges about things. So here I'm going to reset my quiz problem. I just cleared the screen. Control R, rerun this first line, and then let's run this this big for loop over here. I'll explain what's going on as I type it out. So the for here is a keyword, then file right here. This is going to be the variable name that is my looping variable that I'm looping over inside of the shell. The for and the in are keywords, part of the syntax. And the A, B, C, D, E, F, A, B, C, D, E, F, these are all of the things that I'm looping over. Again, in the shell, there are no special data types. Everything is just a string. And so we just put whatever it is that we're looping over right here to the right of the in keyword. And because everything's just a string, we don't have special syntax to separate things for us. So we just use the space to separate things for us. So you can think of this A, B, C, D, E, F as like a Python list sort of, or a list in whatever language you're familiar with. It's just in the shell, we separate our list items with spaces. And then semicolon do. After the do is whatever commands we're going to be running inside of the for loop. So in this case, just touch $file, and then semicolon done, indicating the end of the for loop. I hit enter. And now if I type ls, we'll see what happened. Before I run ls here, though, we are computer scientists. Scientists follow the scientific method. The scientific method is we generate a hypothesis about how the world is going to work, and then we test the hypothesis. And so we don't want to just like look at the results. We don't want to just look at the answers to these quizzes without generating our hypothesis about what's going to happen first. So let's talk through about our hypothesis, what we think might happen, and then we will run our experiment to see if it actually happened. So my claim about the way this for loop is working is that this file right here, this is going to be our variable that we'll be accessing inside of the for loop. So this $ file over here is going to be accessing this file variable right here. And this file variable is going to take on each of these 6 values, A, B, C, D, E, and F. Again, those will be substituted one by one for this $ file variable right here and passed to the touch program. Again, touch creates a file based on whatever the file name that's passed into it is. And so we'll pass in each of these 6 strings one by one, creating a file for each one of those. Type ls, and we can see that there are in fact 6 files created down here, one for each of these files that are in the for loop. So by itself, for loops not super tricky in the shell. They work basically the same as any other for loop that you've seen before, and yeah, just I don't know, maybe slightly different syntax. It looks a little bit weird involving the spaces over here. The do and the done may be different, semicolons. The syntax is different, but the idea is all the same. Any questions so far? Yes. So the question is, how do these semicolons relate to new lines? And the answer is that, yeah, this for loop that I've written right here is a little bit ugly because it's just on a single line. And if we were writing, I don't know, a script somehow, we haven't really talked about scripts yet, but the shell or the lab for this week will introduce those. We might want to have a better formatting for this. And so we could format this differently. I could type for file and all that, hit enter, and we've seen this little angle bracket thing coming up before, indicating that we're in the middle of a shell command right now. It's not the $ prompt, so it's not indicating that we have a new command. It's indicating that we're in the middle of a previous command. And now we can type all of the commands that we want here, part of our loop, like this, touch file, done like this, and we get the same results. So the original question is this semicolon equivalent to a new line? And the answer is basically yes, that I have. This would be a nicer way to read this for loop, but in order to compress things for the quiz problem and put it all in a single line, I use the semicolons to compress that onto one line. Typically, when I am doing things in the shell, I will commonly put things on one line like this because it makes it easier to, say, use the up and down arrows to go back and edit what I was working on. Or if you're in this environment down here, once you've hit enter, you can't go back and fix a typo in a previous line. I don't know, some people prefer typing out things multi-line like this in the shell. I prefer these one-line solutions, that seems easier to me. But as you're working on the labs and homeworks, whatever works for you is certainly fine. Great question. Yes? Yeah, so the question here is related to this touch command, and when I've done this for loop twice, once up here, once down here, what is this touch command like actually doing when it's trying to create a new file? And the answer is that it does not create a new file for a file that already exists. Technically, what it does is it updates the timestamp of the file. So here, when you do the -L, the long version of the ls command, the thing on the right over here is the timestamp that the file is last updated, and the touch command, if you rerun the touch command on the file, it will update those timestamps to be the new value. So if the file exists, it updates the timestamp. If the file doesn't exist, then it creates the file.
So then you want to access the file.
Question is about accessing a file, and many ways to access a file. In this case, all of these files are empty, so if I were to do something like cat in the file, I have no output in it. But I could do things like echo hello world into A, and then cat A, and we access it that way. So cat is sort of our like main workhorse for accessing files. I'm not sure if that was answering your question.
I'll say one.
So in the for loop, I can use whatever commands I want inside of here. So I could do something like cat $file. In this case, only the A file is going to have contents in it because only the A file has been output redirection, and so only the hello world gets printed like this. Something, I don't know, maybe echo contents of $file are command substitution cat right here, and run that. And so echo here has this giant string inside of it. It's double quotation marks. Inside of double quotation marks, the dollar signs get interpreted, and so the file gets replaced with all the different file names, and the command substitution happens over here where we access the contents of those files and print something out for them. It's okay if this is seeming a little bit fuzzy. This is a relatively long for loop right here. In the background material for the lab this week, one of the things that you do, again, you're working with this multiple terabyte data set. And this data set is stored over several different files. And you'll write a for loop that loops over some of those files, doing some of the analysis like you did on the previous lab for each of those individual files, combining cat and JQ and other things like that. How's that? So the question is about special things here in order to generate these lists for us automatically. And the answer is that we can use any tool of the shell for us in order to generate this list right here that we're going to loop over. And that's really the tricky part of using for loops, is generating this list right here effectively. If we look down here through these other problems, we can see that these other problems are combining quotation marks here with this list. So let's reset. I'm going to run through problem 25 here real quick. Control R, CD that, control, and then for file in quote AB, quote CD, quote EF, do, touch, $ file. This, I'm going to put it inside of double quotation marks too. So it's a little bit different. Done. And then ls, and we can see that there's these 3 files down here created with spaces inside of them. And that's because the looping over here is done at sort of like this string level, and these quotation marks are identifying that this is just one string. That's one string, and that's one string. So all 3 of those things get looped together. The double quotation marks over here indicate that they should be treated as a single parameter to touch, and each of those files created separately with their spaces like this. Going on a little bit further, we can see that more and more complicated commands are appearing inside of the for loop up here with command substitution and combining command substitution with strings. And so you can build up very complicated lists of things to loop over using the tools of the shell that we've seen so far. We will see more tools for developing these things to loop over here in a little bit. But even with the ones we've seen so far, you can do complex things. I'm not going to go over any of these other problems sort of one by one because they just combine things that we've already seen before. And so my expectation is that you'll be able to run through these on your own and test them out, figure out what's going on in order to solve these problems. That is the end of all the material for this quiz 1 here. Before we go on, though, any questions about any of that? Yeah. Question is right here with this double quotation. Yeah, the question is, if I did not use this double quotation here and just had the $ file. In order to test that out, let's go ahead and I'll delete everything in this folder, rerun this for loop like this without double quotes, and we'll see what will happen. Type ls, and now you can see there are no quotation marks around these files up here. And what happened is that this for loop is only going to happen 3 different times. It's 1 time, 2 time, 3 time, looping over 3 different times. The file over here taking on just these 3 values. But then when we do the substitution over here, this file variable contains a space inside of it. And so this, the very first for loop, this will expand to touch AB, $file expands to AB like this. And because there's a space right here, A and B are considered 2 separate parameters to this touch program right here, creating 2 separate files. So lots of subtle ways that the quotation marks can trip you up and get you to get the wrong answer for these quizzes. Did that answer the question, Mouse? Yes.
What if it was single quotes?
And if it was single quotes, then again, we're computer scientists, so let's run an experiment to answer this question about what if it was single quotes right here. We'll hit enter. But part of being a scientist is also having a hypothesis. So before checking our result, let's generate a hypothesis. And my hypothesis is that if anytime we're using single quotes, then we do not do the parameter expansion inside of the single quotes. So this value right here will always be the same for every iteration of this for loop, and we will always create the same file. So only one file will be created that is $file, literally. Good questions. Okay, we're going to shift gears a little bit. In general, with lectures, I like to divide up the technical stuff with a little bit of sort of fun background stuff in the middle. So before we get into more technical stuff on the quiz 2 file, we'll start that here in a little bit. Before we do that, though, I just want to do a little bit of background information on the shell and the terminal. And again, this background information, not things that will be explicitly tested, but might help fill in some gaps about why things are the way they are in the terminal environment. So the first thing here is a little bit of technical definitions about the difference between the terminal and the shell. The terminal is the graphical program that you're literally typing stuff into. For me, I am on a Linux machine that uses the GNOME system. GNOME. In the Linux world, there are lots of programs that start with G, and the cool kids pronounce that G with a hard G. So this is not a GNOME system, it is a GNOME system. And that has a built-in terminal called GNOME Terminal. That provides this white background for me. It picks all of its colors like green and red and black, the color scheme that I like, the font size that I like. I can increase the font, decrease the font size. That's all happening in the terminal program on my laptop, not related to the Lambda server in any way. The shell is the non-graphical program that's actually running the commands, in this case on the Lambda server. And it's called a shell because the operating system itself is commonly called a kernel, another word for like a seed, and the shell is the wrapping around the seed, wrapping around the kernel. The shell is our interface to the seed of the operating system. And again, this is running on the Lambda server. So sometimes people call these commands terminal commands, but they're more technically called shell commands because there are many different types of shell sort of environments that could be running inside the terminal, like a Python environment or a SQLite environment running inside the terminal. There are many different types of Unix shells. There's a long history of Unix shells. Ken Thompson is the inventor of Unix and the inventor of the first Unix shell. He's the one who determined this shell name, wrote the program in 1971, called it SH for short. And the shell that we're using today is essentially the same as the original shell that Thompson wrote in 1971. There's been some minor improvements, but it's basically the same. The main improvements came from this guy, Stephen Bourne, who created a new version in 1979, and the shell that we are using on the Lambda server is 100% compatible with this Bourne shell from 1979. These shells, though, are not open source shells, closed source shells, and so there's been a movement starting in the 80s about open sourcing all of our operating systems. And the first one of these shells is the Alchemist shell, ASH, written by Kenneth Alchemist in 1980. It happens to be BSD licensed. BSD means you can do whatever you want with it, essentially. GPL licensed means that whatever you do with it, you have to share that code with other people in the future. So there's a big tension in the open source world between these BSD and GPL licensed programs. And so this guy named Brian Fox, he didn't like the fact that this one was BSD licensed, and so he created this Born Again shell, designing to mimic the Born shell up above, being 100% compatible with it. And this is the shell that's actually being used. There's been 0 changes in the shell environment since 1989 until today that Linux systems use. The Born Again shell, so it's a play on words, harkening back to the original Born shell, going back there again, but also like the religious movement of being you're a born again person after you have a certain religious epiphany, and the people who are part of this sort of GPL movement, they treat it sort of like a religious movement, and so it's a explicit calling out of they are born again people by using this shell. This person here is the leader of that movement, Richard Stallman, and he likes to go on rants about how the GNU system is super important. A lot of people talk about doing bash programming in the shell, but on the Linux systems, on our system, we actually have 2 shells installed. One is called Dash, and the other is called Bash. Dash is a much faster version of the shell, and Dash and Bash are both POSIX compliant, and we want to be writing our scripts, all the shell things that we do, in a way that will be compatible with both the Dash system and the Bash system. Bash is specifically, Bash is for interaction, human interaction. So whenever you're working on the terminal, like interacting with the computer physically, you're using the Bash system. Dash is for scripts that are running in the background. So it's a little bit less user-friendly, but much faster, and hence the name. This, if you're on a Mac system, you are using the ZSH shell. Macs, when they switched over to Mac OS X, they used the BSD operating system as their base, and so ZSH is the modern BSD shell, and they're using that instead of Bash. Other than Macs, everybody else is using Bash as the main shell. Because there's this large proliferation of shells, this POSIX standard was invented to have a common interface that everybody would be comfortable with and know about. And if you design your shell scripts, your programming environment to work with POSIX, it'll work under all of those systems. So all of those shells, again, have slightly different behaviors in different circumstances, but our quiz is focusing on the commonality, the POSIX aspect of the universal standard of minimum features that all of those shells support. And we'll want to be writing POSIX compliant scripts in this class to ensure that our shell scripts will work on a wide variety of systems. And like we've seen so far, there is a lot of weird syntax with quotation marks and $ and stuff. Make your eyes bug out of your head like this. But hopefully within a couple weeks, you'll be very comfortable with exactly what all these different things mean and are doing. Last sort of notes, there have been some movements to create non-POSIX shells. The reason the purpose of these non-POSIX shells is to fix a lot of these warts that we've sort of encountered so far about why do we have so many different types of quotation marks that do different things? Why are spaces treated this weird special way? Why doesn't the shell just work like an ordinary programming language? The 2 most popular are the friendly interactive shell and the oil shell. Those do fix all those problems, but nobody uses them because they're not backwards compatible, and so you can't actually just log into a computer anywhere and start working with them. You have to install a whole bunch of software, and provides a lot of friction. So Bash, again, the Born shell, been around since 1979. It will probably still be around in 2079. And so all the things that you're working with, learning about the shell, definitely things that you will be using throughout your career. See all over the place. Okay, historical aside done. Let's start talking about the POSIX shell 2. And we won't get into too much detail today. We don't have too much time. And again, the stuff that we talk about here will not appear on the quiz on Thursday. So the first thing that you'll notice about this POSIX shell 2 is so starting off with if statements, but there's a handful of other weird syntax down here that we'll need to cover before we can get to the actual if statements themselves. So today in class, what we'll do is we'll cover that weird syntax. And then next class period, we will actually go into combine that weird syntax with the problems in the quiz. So I'll come over here, I will close that window, and we will focus just on the terminal here for a second. Let's clear things out as well. And the first of those weird syntaxes that we're going to see is called a here document. Here document. In the quiz, it's this syntax over here that looks like input redirection. It's these two less than signs right next to each other. We've seen before about just say like the cat command. If you run it by itself, then it's going to output whatever you type as the input. It pipes that to the output. In this case, the output is just our screen. And so whatever I type in, it pipes to the screen. I can press Control-D to end the cat session right there. And all that's done. I type ls, and we did not create any files. I'll use the cat now with this greater than sign in order to do output redirection. We'll put this into a file called test, and now when I type hello world test like this, Control-D, and I type ls, this is in this file test over here. And if I type cat test, we can see that. This is all review so far, and now we're going to see what this idea of the here document is. If I type cat output redirection test, and then two less than signs like this, and then EOF like that, now I am inside of the here document environment. Those two less than signs right here are what creates the here document environment. And this lets me type in whatever text I want right here, and whatever text I want, whatever text I type in right here will be used as the input to this program over here. So I can type in, we'll go Spanish this time, hola mundo, and prueba, Control-D. Whoops. I pressed Control-D, and I'm getting this warning right here saying the here document was delimited by end of file. We wanted this EOF. I should have run this by typing EOF at the end of this line. When you're not using a here document, when you're using this syntax right here, Control-D will terminate the environment. When you're in the here document environment, whatever letters you have up here, that should match exactly what you have down here. I hit enter, no errors, type cat test like this, and we get the new output down here. So far, the here document is not buying us any power that we did not already have from just the cat program by itself. That it's just a way of defining what the input is into this program. The power of the here document is that we can use shell variables inside of the here document. So if I type something like message equals hello world, then rerun my cat greater than test here document and do $message EOF. This message right here will get substituted inside. It'll do the proper variable expansion, and inside of this test over here, it'll contain the string hello world, cat test, and it contains the string hello world. So the cat environment by itself, if I do cat greater than test, $message, Control-D, cat test. The cat environment does not do this variable expansion inside of the documents, but the here document here, this double less than does do this variable expansion. So that'll be the main new tool that we'll need in order to start talking about the quiz material for quiz 2. This is a good stopping point for us for today. Happy to stick around and answer questions about anything if you all have them. Otherwise, I will see you all on Thursday. And again, I'll be here at least 10 minutes before class, so you can start your quiz early if you would like to. Let me stop the Zoom video first.